Good afternoon, everyone. I'm Elizabeth Frankish, and my project is focused on quantitative microbial risk assessment in fruit packhouses. The project is supported by the Fresh Produce Safety Centre and Apple and Pear Australia Limited, and it's part of a drive to improve risk management of fresh produce through the supply chain. Apple juice has been a vehicle for foodborne illness outbreaks of salmonella since the 19th century in Europe, and in more recent years, E. coli 0157H7 in the US. Many tree fruits have been associated with foodborne illness outbreaks for many years, and in Australia, we've experienced outbreaks from orange juice and papaya fruit. In many of these outbreaks, wash water and packhouse equipment have been identified as the sources of the pathogens. Apples are an ideal exemplar industry for this project because of their broad consumption and extensive export trade. There's been little research on the behaviour of pathogens during storage of pome fruit, and post-harvest handling includes packhouse operations with the potential for new and increased contamination. The pome fruit industry is taking a greater interest in customer behaviour and value-added product opportunities. As a consequence, growers and packers will share a greater load of food safety risk burden. For a through-chain approach to risk management, they need a better understanding of their role in minimising risk through the supply chain. Qualitative risk assessments have identified the orchard and packing operation as the primary sources of microbial contamination on fruit. As fruit transfers through a packhouse, pathogens can contaminate previously uncontaminated fruit, or existing contamination from the orchard can be amplified during the packing operation, thereby increasing foodborne illness risk. Microbial hazards originate from water, food handlers, equipment contact surfaces, and the packing shed environment. Insect and bird damage and bruising on fruit also contribute to microbial loads entering the packhouse. Current practice in the industry is for wooden bins to be placed on the ground for harvest. These bins can become contaminated with manure or animal droppings, or the fruit might be contaminated from birds and rodents. The bins of fruit are then transported from the field and fully immersed in the dump tank water, which may or may not be treated. The dump water is used all day and accumulates a high organic load, so in any case, adequate control of sanitation is difficult. By the end of the day, you have a bacterial soup. The apples then travel over multiple brushes and conveyor belts, food contact surfaces that are cleaned and sanitised infrequently in a packhouse, and they're difficult to clean. The fruit is then graded into flumes and moves onto packing lines. Flume water is sanitised mostly with chlorine compounds that are manually monitored at intervals. The level of chlorine and monitoring frequency is determined by each packhouse operator, and target chlorine ranges anywhere from 3 to 50 parts per million. Flume water is used for many months. It could be up to 18 months in the more sophisticated packhouses, posing additional challenges to sanitation, and we know little about biofilm formation in these systems that might become a source of pathogens. The apples are then put into bins and tubs for controlled atmosphere storage of up to 11 months. So could the unexpected happen in Australia? This project aims to quantify the risk from contamination of apples with the pathogens Salmonella, Listeria monocytogenes and E. coli 0157H7 that could find their way onto and into the fruit from these sources and pathways. Survival and growth data for these pathogens will be used in conjunction with key growing and packing parameters to build a risk model that equips growers and packers with a tool to measure that risk in their operation. Although growers and packers apply good agricultural and good hygienic practices and comply with certified quality assurance programs such as Fresh Care and SQF, they don't know the absolute food safety risks that exist. The key practices and input controls specific to apples that provide the highest level of due diligence in food safety are being identified as part of this research. The industry doesn't receive any formal guidance on how to conduct risk assessment or how to establish the relativity of risks. Quality assurance managers are each left to determine what the hazards are, where the risks are, and how to mitigate those risks. Without the measure of a risk, it's difficult to know how to respond appropriately. Effective risk assessment is an active, continual process and is often a balancing act between food safety considerations and operational imperatives. Risk assessment must respond to changes in operational conditions and operational parameters in use or a looming crisis, and evidence of the effectiveness of risk management needs to be readily available. Changes in staff responsible for risk assessment would be less challenging for business if tools are available to more easily train new personnel in understanding their responsibilities and where they should focus their energy. If the risk manager has a quantifiable measure of risk and the means to identify how to lower it, it becomes impossible for them to ignore the appropriate action. They must act on the findings. This project will deliver a range of resources and tools that provide a consistent and more objective measurement of microbial risk, thereby providing the means to demonstrate reliability in the supply of safe product. I will develop a code of practice for the pome fruit industry to better understand risk assessment in the context of operational procedures. This code of practice will identify the variables that have the most effect on risk and how they should be managed to mitigate that risk. It will contain recommendations for best practice and will complement existing quality assurance. I will develop a risk model based on established principles of food safety risk assessment and incorporate it into computer software that can be easily understood and used by industry. It will make use of both qualitative information and quantitative data. The harvest to consumption pathway will underpin the software tool, and it will provide a risk ranking for apples out of the pack house. This will provide a measure of the relative contributions to risk associated with each packhouse operation, and so allow focus on the most important, urgent and effective risk mitigation strategies. The model will incorporate specific on-farm and packhouse inputs identified as having the most contribution to contamination with microbial hazards, such as water sanitation, temperature and atmosphere. Based on the risk assessment model developed, the relevance of current microbiological criteria assigned to fruit will be assessed, and as appropriate, revised criteria will be suggested. Worked examples of the use of the model and risk management decisions based on it, using anonymised data, will be used to communicate the outputs of this research to industry. The information and tools provided by this research will allow focus on those factors in crop production, packing, storage and distribution that most affect food safety risk, and provide the means to measure and control that risk. This will result in a risk assessment process that responds to changes in operational and management practices. As a result, resources and effort can be targeted to the activities that will have the greatest and most effect on food safety control and risk management strategies. Whilst the main project focus is on activities early in the supply chain for apples, the findings are likely to have application not just in fresh product, but also to processed or value-added products. Use of the software model will demonstrate the highest level of preventative risk mitigation to auditors, the supply chain and regulators, and optimise consistency in risk strategies across the industry, thereby reducing the likelihood of a potential crisis and the attendant negative publicity, and providing a safer pathway to future trends in fruit products and niche markets with the ability to upscale as business grows. Thank you.